This video is part of the Node.js Passport.js user authentication series. The playlist for that series is in the video description, and you can go check that out from the beginning. If you're following along with that, then welcome back. Today we're going to be talking about JSON web tokens. And before we get started, I would recommend that if you haven't watched it already, watch the video on public key cryptography or asymmetric cryptography that I made, which is in the playlist. I've also separately linked it in the video description. It's going to help you understand what's going on in this particular video a lot better. The questions that I'm going to answer in this video is first, what is a JSON web token? We will then go into answering the question of how do we derive a JSON web token, like what are the pieces of it and how would we actually create one using code. And then finally, I'll give you a little bit of context as to how it applies to user authentication among other use cases. We'll start the video off by looking at the JWT or JSON web token spec on the Internet Engineering Task Force. It is going, let me switch to Google Chrome real quick. You'll see that they have a write-up on JWTs and the specification for using them. We'll come back to this in a minute to look at a few things, but this is a very well-established type of token per se. I guess you could call it a token that we use to transport some sort of data on the web. Now, something a little bit more friendly that we can look at is a website called JWT.io. And right here, I am looking at the example JWT. And we're going to be able to visualize what is going on a lot easier. Once we kind of understand what the JWT is, we'll actually go into writing some code to kind of replicate this example right here. So, to understand a JWT, it's pretty simple. There are three parts. You have the header, the payload, and the signature. Now, the header and the payload, pretty easy to understand. The signature, not so much, because there's actually multiple types of signatures that you can do, and therefore it adds a little bit of complexity. On top of that, a signature is a digital signature, and it has to do with public key cryptography or just symmetric cryptography, depending on which algorithm you're using. So it requires a little bit of background knowledge, which is why I recommended watching that video that I had created on public key cryptography before this one. Now, you'll see in the algorithm field up top, we can kind of scroll through all of the different choices that we have for writing a digital signature on a JWT. But in our case, since I had you watch the public key cryptography video, we're going to do the RS-256 algorithm, which is basically, as you'll learn more when we get into the code, is telling us two things. So number one, we're going to use RSA private and public keys, that's standard. And then number two, we're going to use the SHA-256 hashing function to actually take a hash of the header and payload data. I know that's a mouthful. We haven't learned anything yet, so just hold on to that knowledge in the back of your head. We'll come back to it and understand it in a lot greater detail in a few minutes. Let's start out by getting a basic understanding of what a JSON web token is. So I mentioned that it was made of three parts. You have the header, the payload, and the signature. And these are highlighted on the page here in the different colors. And they are separated by a single period. So the first part in red is the header, then you have the pink part, which is the payload, and finally this turquoise part is the actual digital signature. Now, what you're looking at right here is base64 URL encoding. And I'm not going to get super into it, but just a few fun facts about base64 URL encoding. It's a encoding spec that basically aims to standardize character sets, and it's derived from the base64 encoding, which was originally created well before my time of learning to code, but from what I understand, the idea there was previously, before the UTF-8 standard, where we had standardized character sets, there was debates over whether there should be 4 bits or 5 bits or 7 bits or 8 bits within a single byte of data. And before that was standardized as 8 bits per byte, there was varying use cases, and different protocols and applications would use different number of bits in a byte. And so therefore you might have an application that actually cuts off the last 2 bits of data. So what base64 was aiming to do was basically add this thing called padding into the data, and so it makes it so that there's no chance that any of the data is going to get lost in transport. And then the base64 URL encoding is just one extra step, because there were some characters within the base64 encoding that are not exactly URL friendly or file name friendly. So converting base64 to base64 URL just makes it safe to transport over the internet, and we also know that this format in general is not going to lose any data, which is obviously very important when we're talking about user authentication, which is a very common use case for JWTs. I know that was a bit of a long-winded explanation of an encoding, not so interesting, but as we actually derive this JWT with code, you're going to see that we're kind of constantly having to shift between the different encodings, and it's going to become a little bit more important later. Alright, now that you know what you're looking at here on the left, let's talk a little more conceptually what we're seeing here on the right side. So on the right side, all we've done is we've taken these base64 URL encoded characters, and we've decoded them into JSON objects. And in the header, you'll see that we just have a couple things. We have an algorithm and a type. And this is pretty self-explanatory, but when you're transporting JSON web tokens over the web, it's not always the case that the receiver of the JSON web token is going to know, anything about the JSON web token to start with. So in the header, the sender of the JSON web token, or the issuer, is going to identify which algorithm they use to create the digital signature. And then of course we say that the type of token is a JWT, because there's actually other types of tokens that we can use here aside from just JSON web tokens. So we have again chosen the RS-256 algorithm, which says we're using public key cryptography for the digital signature along with the SHA-256 hashing function. And what we're going to do is, well, actually before I get into this, let's cover what the payload is, then we'll get into that signature. So the payload is basically going to be metadata about some entity. And in most cases, it's going to be about a user, because JWTs are commonly used for user authentication. So in this payload, you're not going to see any sort of credentials. If you see credentials in a JWT payload, then you know that the developer has done something wrong, because you should never ever put credentials or sensitive information in the payload. It's publicly available. Anyone could decode this JWT just using a simple base64 URL decoding algorithm. So what this data gives us is just general information about the user. So you'll see the sub or subject is going to tell us who the user is. In many cases, you'll see some sort of database ID put in here, so that when an application decodes a JWT, they see, okay, here's the sub, it is this ID, let me look up this ID in my user table and retrieve the full user object. So that's what the sub is. Name, obviously just the name. Admin, just another metadata property. And then IAT is issued at. So it gives you the timestamp of when the JWT was issued. Now we also have additional what they call claims. That's kind of the proper term for these pieces of data. We have additional claims that we can define. And if you go over to the specification for JWTs, you have all this information, but down here at the bottom, or somewhere in the middle, we have the registered claim names. So these are registered. It says the following claim names are registered in the IANA JSON claims registry established by section 10.1. So in other words, these are kind of the official claims that you'll be using, and if you wanted to issue JWTs that would be interpreted by various applications, you would want to use these standard claims so that everyone knows exactly what they mean. So let's just go through the most common ones, and then there's a few others at the bottom you can look through on your own. So first is the issuer claim. This is going to identify the issuer of the JWT. Now in our case, we probably don't need this because we are both issuing and verifying a JWT within the same application. But in many cases, for more complex architectures, you'll see a certificate authority who is actually the certificate authority acts as the third-party authority that is trusted to issue JWT tokens, and that is literally all they do. So we basically can establish a centralized authority that everyone trusts, and that centralized authority will sign the JWTs with their private key, and because they sign it with their private key, they'll say, okay, here's our public key, and anyone in the world can say, okay, I trust that institution, and I'm going to verify this JWT with their public key. If it matches, I know that this JWT was issued by a trusted authority. So that's kind of where you'll see the issuer claim. The subject claim we already covered. The audience claim is going to generally be the resource that will accept this JWT. So in other words, if the JWT is only intended to be used with a specific application, it would probably list some sort of URL or base URL that will identify which server the JWT is valid for. So in other words, if Google issued a JWT token, they might put in the audience claim www.google.com, and if the JWT is attempted, if you attempt to use the JWT in a different context other than google.com, it's going to be rejected. And then finally, we have the expiration claim, which basically tells you when or what point in time this JWT token is no longer valid. There are additional claims that you can put in here. We saw the IAT issued at claim, but you can also, and this is important, you can also make up your own claims. This by no means has to be standardized. You can put whatever metadata that you want in the payload. And last but not least, we have the signature at the bottom. We've already kind of touched on it. I talked a lot about how this actually works from a cryptography perspective in that video that I asked you to watch before this one. Again, link is in the description for that. But anyways, I think it would be helpful to go through kind of a conversation between the server and the client to understand how this JWT is working in real life. So I've put together a basic little representation of this, and what we have here is what I kind of perceive as the conversation that the server and the client would have if they could talk to each other, in human terms, of course. So the server, just think of this as any application. We're kind of removing the idea of certificate authorities from this basic equation. We're just going to assume that the server we'll just say it's an Express.js application, is both issuing and verifying the JWT tokens. So we don't have that third-party certificate authority in this equation. So what's going to happen is our client, or just basically our user, someone sitting behind a computer who is visiting our application on the web, is going to go to the login page and say, hey server, I want to log in to your application. Here's my username and my password. Then the server gets that information in the form of a post request, and it's going to say, okay, let me check on that. I want to go through my verification algorithm and look you up in my database to make sure that you exist and you entered valid credentials. We'll assume that the user did, so the server says, okay, your credentials look great. I'm going to sign a JWT token or JWT with my private key that only I know about. So the server is the only entity that has any knowledge of that private key. They're going to sign it and send back the JWT in the response body. So then the client or the user, basically this doesn't actually have any user interaction. It's invisible to the actual person behind the computer, but the browser or the front-end application is going to receive the response and say, hey, thanks for the JWT. I'll keep this stored in my browser's local storage until maybe it expires. So then the client is going to, once they're logged in, they're going to want to do something. So maybe this client wants to go edit their profile. So they'll type in the URL of the profile, just say somesite.com. This is just an arbitrary value. And then they're going to need to attach that JWT token, or I keep saying JWT token, but it's JSONwebtoken, to the HTTP header that's called the authorization header. And so in the authorization header is where that's going to be stored. The server is going to receive that JWT in the request body, and then we're going to say, okay, I just talked to you, we're familiar, but I still need to verify that JWT because I don't know if in the time that you chose to visit the profile, did someone tamper with it. So we're going to take the JWT, and now the server says, okay, I signed it with my private key, but now I'm going to take my public key that everyone knows about, but I don't care because it doesn't actually matter. I'm going to take that public key and verify the signature on that JWT. And the server says, okay, that signature is indeed valid. I know that you are actually you, and the claims made on the body of this JWT are valid. Let me go ahead and look you up in the database, load your user profile, and give you the information required to actually edit that user profile. So that is the basics of how a JWT works. I'm going to, in a few minutes, go through the code for deriving a JWT, but I will also mention, again, this video was intended to be kind of part of my Node.js, Passport.js video series, which the playlist is listed in the description below. If you wanted to know more about what we just talked about, how this actually works in practice, written in code, say for an Angular application, go ahead and follow that series through the end. Use the Passport JWT authentication strategy, and you'll see exactly how this works in practice. But for now, we are going to jump into the code editor and actually see this process written out, how we issue a JWT and then how we verify that JWT just using the built-in Node.js crypto library. To start off with, we're going to go through this part where we issue a JWT. To keep it as simple as possible, I'm going to take the example off of jwt.io. So if you visit this, you should see the same thing. And I'm going to actually be showing you how we get to this JWT, how we actually issue this one, and then how we verify it using the public and private key. So you should be able to verify how this works by just coming to this site, and you can actually follow along with the Node.js crypto library. So I'm going to go ahead and just copy this entire token. Again, this is in base64 URL format or encoding. So I'm going to copy that, and then we're going to come into the code editor and paste it in here. So I first need to create a file. So let's just say issue jwt.js. And you can see that on the left here I've already pasted in the private and public key. Those came from that jwt.io website. Alright, so I've copied in the key right here. Let me just put this as a string and store it in some sort of variable. So we'll say const JWT equals that. So this is the exact JWT that we saw from that example website. Now, in order to properly do this, we need one npm library, and it's called base64 URL. So I've already installed it, but you'll come down here to your terminal and install base64 URL to follow along with this. So I'm going to go ahead and require that in real quick. So we'll say base64 URL. And now we can take this JWT right here and convert it into something that we can actually work with. We now need to split up this JWT into its parts, which, if you remember, is designated or delimited by this period. So we can do that using some simple JavaScript. So we'll say JWT parts equals JWT.split, and we'll specify that period. So now if we were to console.log the JWT parts, we should have an array of those three parts. So let me go ahead and try that real quick. And you can see that we have an array, and the array contains the three different pieces of that JWT token. Again, these are still in base64 URL encoding. Let's go ahead and split these into variables. So I've just written this code already. We basically say header in base64 URL format is going to be the first one. So in our array right here, we're just grabbing that piece, and then so on and so forth with the remaining two. Now what we have to do is we have to actually take this base64 URL format and convert it to something else. Now that we have this in pieces, we can decode this with the base64 URL decoder, the npm module we included up here, and we can see the actual JSON objects that these represent. So let me put those in variables real quick. So we have the decoded header, payload, and signature, and we're just using that base64 library and using the decode method, and we're passing in the base64 URL pieces. And then finally we can console.log those to the terminal, and you can see what they look like decoded. So let's go ahead and console.log those. So we're just taking these three variables here and logging them. Save the file. Let's give us some space in the terminal here, and let's run this again. So you're going to see the first part is the same thing that we saw on Google or in the browser at jwt.io, and the second part also. So these match perfectly as we would expect. And then we have a bunch of gibberish at the bottom, and the reason being is because we haven't actually decrypted the signature yet. So once we decrypt the signature, then it will be in a format that we can understand a little bit better. Now that you've seen this decoded, I'm going to actually comment all of this out for a second, because we don't need this. We're going to actually derive this JWT from scratch. So commenting that out for a second, we'll just space it down to the bottom. And what we're going to do is actually create this from scratch by first creating the JavaScript objects that we want to put in the header and the payload. So you can see that these are the exact same header and payload objects that we printed in JSON format below. Now obviously these are in JavaScript format, so we will need to convert them into JSON format by using the JSON.stringify method. So let's do that right now. I pasted in the JSON.stringify method and stored these two objects as JSON strings in these two variables. The next thing that we have to do, because right now these are just in JSON format, we need to actually convert that JSON format into the base64 URL. So to do that, we'll use this base64 URL library, and we'll just put it through the basic function and convert it. So here we go, copy this in. I'm just copying code that I wrote before to speed things up. But anyways, we have new variables. Hopefully these are labeled appropriately for you. But we have a base64 URL header and payload. All we've done, and we actually need to change this a little bit. So we're going to just use our import here, base64 URL, and the basic function that comes with that library is just a function to convert any sort of object into the base64 URL format. So these two variables store the correct format for our header and our payload. Now we have to actually sign and issue the JWT. But first, let's go ahead and check this. We're just going to console log these two values to make sure that we have actually converted these original JavaScript objects correctly. So let's go ahead and clear the terminal, give it some space, and run this again. And you'll see these two values, which we can actually check from the commented out code. So here's our original JWT that we just took from the website and posted right in there. And you'll see that this first value matches the first value of there, and then the second one, if you wanted to go out there and confirm that, it also matches. So we've got what we need. Again, the last thing we have to do is actually take some sort of hash of these two pieces of data and then sign that hash and put that in the signature. In order to sign this, we need to import a few more libraries. So at the top, I've imported the built-in Node.js crypto library. And then from the crypto library, we can also implement the algorithm that we're using for this JWT. So this is going to allow us to sign the JWT using this specific algorithm. And then we need the file system from the Node.js framework so that we can access the private and public key that we have saved in this current directory. Now that we have our imports, let's come down here, get rid of these console logs, and we're going to create the signature. So the first step is to use this signature function, and we want to write some sort of data into it. So right here we're just passing in the header and the payload separated by this period, and this is going to be the data that is actually hashed using the SHA-256 hashing function. This is all kind of done within this Node crypto library, but we're going to hash this data and then we're going to sign the hash. So we've loaded the data in here. The last thing that we have to do is load our private key, which we're going to be signing it with, and then use the signature function sign method to actually sign the JWT. Here's the code to do that. Copy it in. First, we need to load our private key. That's literally just loading this private key PEM file. And I actually need to change the name for this to work correctly. So private key.pem. And it's important to put this in UTF-8 encoding. And then we are going to convert. This is kind of an important part. We are going to sign this data, which is going to give us a base64 encoded signature. So then to actually derive the JWT, we're going to have to convert base64 to base64 URL. We can do that with this imported library right up here. So I'll show you the code for that. Here's the code that we use to do that. So we just basically take the signature that we got from the Node crypto library and we convert it from base64 to base64 URL. So now the signature should be in the same exact format that we were expecting earlier. Let's go ahead and verify that real quick. So signature base64 URL. We'll print that out really quickly. And you're going to see this value right here. Let's go ahead and just verify it real quick. So here again is our JWT. We need to come all the way out to the last piece of it. And here we go. There's the last piece. And you can see that the first couple letters are matching up. And if you were to go through all of it, it's going to match to the character. So right there, we from scratch created a JWT token using the Node.js crypto library. Now there is an easier way to do this, and I will show you that in a few minutes, but first we need to verify this JWT that we just issued. Since we already have a lot of the basics set up, we're just going to uncomment some of this code to verify the signature. So let me just make a comment for this first part. Probably should have just named this file JWT because we're doing both the issuance and the verification in the same file. So here is the issuance part right here, and then end of issuance, and then here is the verification, and we will go ahead and implement this now. So when we verify a JWT, we are basically receiving the JWT in the base64 URL format. In this case, we just are going to use this one right here, the one that we just created, because we know that it's exactly the same as that example online. So to get the JWT parts, we're going to uncomment that. We will uncomment this part. We don't need any of these things right here. And I think we're set. So now we can actually verify this JWT. To do this, we'll actually have to just create one more line in the imports, and this is going to be the verify function from using the same exact algorithm. So we've got the issue or the create JWT function, and then the create verify or the verification function. As the verifier of this JWT, we have received the entire JWT right here. We've split it into parts, and now we have to actually do something with those parts. So the first thing we'll do is we'll take the header and the payload, and just like the signer of the issuer of the JWT did, we're going to take the header and the payload and append them together, separated or delimited by the period. And since the Node.js crypto library only accepts base64 encoding, we need to take the base64 URL signature and convert it using the base64 URL npm module to base64. So now that we have that, we can finally, I guess, decrypt the signature. So we're going to take our public key that corresponds to the issuer's private key, and we're going to decrypt the signature. So the first thing we need to do is actually get the private or the public key in here. So I'm going to just copy this line and use that. We'll say public key, and we just need public key.pem. So now that we've imported our public key that we're verifying with, we are finally ready to verify this JWT. So let's copy this in. The signature is valid variable is basically going to run the Node.js crypto library verify function that we imported right here. So verify function dot verify, we're going to pass in the public key that we imported from the file system. We're going to pass in the JWT signature base64 format, And then the most important part, this will really trip you up. It took me honestly hours to actually get this to work because I had not included the base64 format in the verify function. So that's really important, and once you've done that, we should console.log the signature is valid, and I think it returns a Boolean whether it's valid or not. So let's go ahead and try that really quickly. Node issue, well, it's not really issue JWT, but bear with me. We get first the signature that we were console logging right up here, and then the signature is valid variable returns true. So we have successfully verified this JWT, and essentially we've gone through the whole process. So we created the JWT from scratch, and then we verified it from scratch. Now, if you wanted, you could use all the code that we just used in this example for your web applications to sign and verify JWT tokens. But like I said earlier, there is an easier way to do this, and that easier way is using the JSONwebtoken NPM library. And what this library is basically an abstraction of the Node.js crypto library, and it gives you a little bit more options, because in this example we were just using the RSA 256 algorithm, and we didn't even get into, okay, what if we use a different JWT algorithm? So the JSONwebtoken library is going to give you a lot of flexibility, and it also kind of abstracts away all of the things, all of these, when we have to convert from base64 URL to base64, you don't have to worry about doing that in this library. So this would be the library that I would recommend using in any sort of web application where you're issuing and verifying JWTs, and in the next few minutes I will show you exactly how to use it. To save us a little bit of time, I've just copied in my implementation of the JSONwebtoken library if we wanted to accomplish the same exact things that we did with the Node crypto library. Now obviously, since this is abstracted a little bit, you're not going to get to see the little bits and pieces that are happening, and you don't get to truly understand what is happening with the JWT, but it does make your life a lot easier when you're actually coding. So let me explain to you what's going on here. The first thing you'll notice is I imported the JSONwebtoken library. I already installed it with npm install JSONwebtoken. So that is what that import represents. We used the file system, the Node.js file system, to grab the public key and the private key that we were using earlier. So again, this is the public key and private key from that example on jwt.io. And then you'll notice this payload object is very similar. We've seen it before because it's the exact same payload object. But you might notice that you don't see the header. And the reason being is that is one of the things that this library abstracts away. All we have to do is provide the algorithm, and the library creates the header on its own. So you'll see in this next line we have a variable called the signed JWT, which is a product of the JSONwebtoken library sign method, where all we have to do is pass in the payload object in JavaScript form, so we don't have to do any of that JSON.stringify stuff and then convert it to base64 URL. None of that. We can just pass in a JavaScript object. Then of course we pass in the private key that we want to actually sign it with. As we know, that's how JWTs work. And then finally, in the options object, we just have to give it the algorithm that we want to use, and based on this algorithm, the JSONwebtoken library is going to figure out what the header needs to be. So it will then combine that header and the payload, just as we did with the Node crypto library. It's going to sign it with, I actually think they used the Node crypto library underneath the surface, so they pretty much do exactly what we did earlier to sign this. And then to verify it, again, just one simple line of code or a couple simple lines of code. We just use the JSON web token verify method. We pass in the signed JWT, or this basically it's going to be received in the authorization HTTP header for a web application. So we take that JWT, pass it into the verify function. We use the public key that corresponds to the signer's private key. In this case, since we're doing the signing or the issuance and the verification, it's just these two, this key pair. And then again, we have to pass in the algorithms that it will accept. In this case, RS-256. And then we have a callback function. In the callback function, if there's an error, we know that the verification has gone wrong, and either we have the wrong public key to verify this JWT with, or the JWT was tampered with and we don't want to use it. So let's go ahead and just verify that this works really quick so you can see it in action. I will console.log the signed JWT value. So let's just do that first really quickly. And you'll see this value right here, which if you were to match with the value online, it's going to be the same exact thing. So you can do that on your own time, but just trust me, that is the same exact JWT. And then here we can go into the callback function, and let's say console.log error, and we should expect that we don't see any error whatsoever because we verified this successfully. So we get null as the error as expected, and then we can also console.log the payload, which is the second argument that it returns, and you should get the same payload that we had defined right up here, except this was when we issued it and then this is when we signed it. So you can see how this might work in an actual application. You might have a post route that is going to verify credentials, and then it will sign and return a JWT in the response. And then you might have another couple routes that are like authenticated routes, and you might have some sort of middleware like Passport.js that is going to, underneath the hood, use this JWT.verify method and use the public key to verify the JWTs that are being passed through the authorization headers. So again, if you want to see how that's actually implemented in a web app, in the description to this video, I have listed the playlist to the Passport.js authentication series. You'll skip to the second half of that series where I talk about the Passport JWT strategy, and you'll see exactly how we use this JSON web token library along with some middleware to authenticate users into a real-world Express application. I know this was a long-winded video, and if you made it to this point, congratulations. It takes a pretty long attention span to get through all of this material. But then again, we never said that user authentication was supposed to be easy. It is inherently a very difficult subject to understand, and although it might seem easy on the surface, especially if you are abstracting away all of these details with some sort of middleware or other library, if you're trying to debug user authentication or implement your own strategy, you really need to understand all the concepts that we just talked about. So if you liked this video, if you found something useful in it, be sure to give this video a like and subscribe to my channel. If you're continuing on with the Passport.js series or you want to start it, link for that is in the description below, or you should just be redirected to the next video.